This is one of a series of videos designed to introduce you to the various features and capabilities of SQL Data Warehouse. My name is Alan Jordan. I am the Product Owner and Development Manager for the SQL Data Warehouse software. In this video, we'll explore the various data integration challenges that virtually all organizations struggle with in today's world. We will then review how SQL Data Warehouse addresses these challenges and follow that up with demonstrations. Most organizations today struggle with the many different data sources that they need to access and bring together from an analytics or reporting perspective. It's not uncommon to have data spread across 3, 4, or more different platforms and databases. IBM data on Power Systems, Microsoft SQL Server on Windows, Oracle or MySQL on Linux, proprietary databases or data sources such as Salesforce in the cloud, and so on. The possible combinations are almost endless. These databases do not easily talk or share with each other, especially when developed by different vendors. The technologies, access mechanisms, and required credentials are all quite different, representing a huge challenge for any business intelligence or reporting efforts. A data warehouse can solve these issues, but only if it can easily access and load data from all the sources that your organization uses. We are going to explore how SQL Data Warehouse approaches these challenges. SQL Data Warehouse builds data warehouses on IBM using its inbuilt database. I'm guessing you already know that, and since you're here today watching this video, it's a fair assumption that IBM is your primary business platform, and you're considering it for your data warehouse too. So firstly, let's look at how we can access DB2 data. Some organizations find it expeditious to build their data warehouse on the same LPAR as their primary business applications, your ERP application, and so on. This makes access to the operational data very easy. However, it's quite common for organizations to build the data warehouse on a different IBM LPAR. In that case, your operational data will be remote. But since it is IBM, it doesn't present any significant challenges. There are two options available. Firstly, you can use DDM files. SQL Data Warehouse will create these automatically for you, or you can create and manage them yourselves. You can also use remote SQL to access the remote data. The technology is different with these two approaches, but there's little difference in usage from an ETL perspective. Whether local or remote, SQL Data Warehouse can use DB2 data directly in an ETL process. This also applies to DB2 data on other platforms. This is the great thing about DB2. IBM has ensured that DB2 databases can talk to each other regardless of the technology platform. Unfortunately, for other database and platforms, it's not as simple. Each database or data source will have its own unique challenges, which possibly require different access mechanisms. Directly accessing and joining different types of data in the same ETL process is very difficult and would complicate the ETL process immensely. It's not a recommended approach. The accepted best practice in loading a data warehouse is to use a staging area to first stage the remote data on the data warehouse system without attempting any joins or transformations. This is our approach in SQL Data Warehouse for virtually all non-DB2 sources. Let's take a more in-depth look. SQL Data Warehouse is a really easy process to access remote sources. Connectors for all commonly encountered remote sources are supplied with the software. Notice that DB2 is on that list too. Even though you can access it directly in the ETL, you could still stage remote DB2 data if it makes sense to do so. Even though Excel and XML files are not databases at all, the connectors we supply make them appear to be database tables, making them very easy to access. Regardless of the type, SQL Data Warehouse handles all of these sources in the same way, automatically creating local DB2 staging tables based on the remote table, and then providing the mechanism to load and stage the data on demand. While not supplied with the software, there are other third-party connectors that are available. Many of our customers also access Salesforce data and big data sources such as SAP HANA and Cassandra, and many others are available too. Finally, there are two other categories of data sources. Firstly, it's common to need to load from text files. Providing the text file is accessible through the IFS file system, it can easily be used directly as a data source in the ETL process. There is a one-time setup involved to describe the data in the text file, but it's not difficult to do, especially if it is a delimited file. The last type of data source is through the use of change data capture from journal images. This process creates local DB2 capture and apply tables, which capture the data from journal images and can be used as local DB2 tables in an ETL process. This change data capture or CDC process will be covered in a separate presentation and demonstration. So let's now go into a demonstration. I've got the SQL Data Warehouse client started, and I'm working in this development environment for my Beachboard demonstration system. So we're going to go into the data acquisition folder, and first of all, we'll look at the source groups. So data sources are organized by group, and each group is specific to a type. For example, I have a Microsoft AdventureWorks database source group here, so the type is MS SQL. And I have two different DB2 local groups. These are pointing to DB2 tables in a library on the local LPAR. I also have a DB2 DDM group. So I'm going to introduce a DDM table pointing to a table on a different LPAR. In this case, the LPAR name is Sparrow, and also a remote SQL group. So this is also pointing to Sparrow, but this time accessing the DB2 tables via remote SQL instead of using a DDM file. And then finally, we have a text file group where this is going to access IFS files on the IFS file system. So those are the groups. Each group has its own folder under our data source definitions folder. So firstly, we're going to look at this transaction group. So this is DB2 local, which means it is pointing to files or tables in a library on this LPAR. I already have one definition here that exists. This is for the invoice line transaction table. So I'm now going to introduce, and that is introduce is our term to bring in the metadata to describe the data source. So I'm going to introduce the invoice header table. So I click the new button, confirming that I'm going to introduce a DB2 local into the transaction source group. Click next. So needs to know which library I want to bring in this table from. I have a list of libraries at the top here, and it's already selected the library that I want to use and showing me a list of available tables, and I'm going to introduce this invoice header table. Click next. If I happen to be a JDE shop and this was a JD Edwards table, I could also specify the data dictionary to use to get extended definitions and attributes of columns in this table. It's not a JDE table, so I don't need that. But I do want to identify dates and times. Many IBM i legacy applications use numeric columns for dates and times. And as part of the ETL process, we want to understand that these are true date or time columns and treat them as such. So I'm going to check, yes, this does have numeric dates, date and times, and I can select the format that the dates are in. They happen to be in this 4-digit year, month, day format, which was the top one in my list. I click next. Here I can just simply give it a descriptive attribute to tell the definition what type of data this is. This is actually a transaction header table, so I can select that and click next. Okay, I can type a few words here, or a lot of words, to describe the purpose and usage of this table, and click finish. There we are. That's it. We're done. So we've captured the column definitions in our metadata, and notice over here we have, in the date/time format column, we have a number of columns that have been identified as dates or times. So let's look at this invoice date one. At the database level, it's simply a packed decimal column with 8 digits. But our extended definition, which we call the source element definition, has identified it as a date, and it has specified it as the date format that we advised earlier. So from now on, in an ETL process, this will be treated as a date. I can do things like extracting the year from the date, the month from the date, etc. Okay, so let's now move on to DDM files. So I've selected my DDM group, click New. Again, confirming what I'm doing. Now I have an option of either introducing an existing DDM file or creating a new one. So I'm going to create a new one. The name of the DDM file that I'm going to create now, I'm going to introduce the customer master table from the Sparrow LPAR. So I will call it cust mast DDM. And it has identified, oops, I missed the M there, so let's add that. Sorry, customer data, 10 characters is my maximum. And the remote file is custmast in library. That's the library name on the Sparrow system. Again, I can specify the date, the format for numeric dates. This one happens to have a date in century, year, month, day format, so I will select that. If you get this wrong, you can correct it afterwards. Next, type some text and finish. There we go. So we've now actually created a DDM file pointing to the system Sparrow, and this is the definition of the table on Sparrow, and here is our date column. Again, we've automatically identified as a date, and this time it's in century, year, month, day format. Let's now go to our remote SQL and do the same thing for the same remote table, but this time say to access it via remote SQL instead of creating a DDM file. The schema is the library name. The remote table is custmast, and we'll call it custmast on Sparrow. And okay, next, same selection criteria here again. Again, we're going to say it has a numeric date, finish. There we go, done. We didn't create any local definition here. It's simply a definition of this data source in the metadata itself. Let's move on to our Microsoft SQL Server database. Before we go to create a data source, I'm going to go up to the source group and bring up the properties. Each source group has different properties and attributes according to the source group type. For a Microsoft table, we need to use a JDBC driver to make the connection. So the first choice I can make here is which JDBC driver do I want to use. We're using the 9.2 driver. Both of these drivers are supplied with the software. Now go to connection properties. What is the name of the remote system? So this could be its IP address or its fully qualified host name. and the date name of the database that exists on that system. If I needed to use TLS or other connection properties, I could define them here. I'm not using TLS. This is one of my internal systems, and the attributes, the credentials that I'm going to use to make the connection. So I can click here, test connection, and make sure that I can contact that. Okay. Click cancel. So that's my database definition. So let's now start to introduce something from that database. So I'm going to click new here. And next. And copying the name of the table because I can never remember it. That is it's a sales order header. The schema it exists in is sales LT. So this time we're going to create a staging table. So this is the local table. This is the table that the software will create automatically as a DB2 table to stage that data. So suggesting a name of sales order, the first 10 characters of the remote table name. I'll just call it sales ADV. Call it ADV order header. And as a local object, it needs to be owned by somebody and also be we can secure it by an authorization list. So I will leave the defaults there. Click next. So it's now contacting the SQL database, retrieving the column information for that table and showing me the columns that exist in that table. I can choose to include all of the columns in the remote table or just the ones that I'm interested in. I'm going to include all of them, but I'm going to exclude this comment here. I've looked at the data and none of the records in the database contain a comment, so I don't need to bring that in. Row GUI doesn't mean anything to me, and I don't need the modified data, but I'll leave all of the others. Select next. Again, some text to describe it, and finish. Here we go, done. The only thing that's different here is this is the SQL name, the remote name for the column name in the remote table. But because it's DB2, I also need what we call the system name, the short name. So it generated short names, unique short names based on those original names. I can see the original type, the native data type in the SQL database and how it's been implemented in DB2. Not all data types are matching. For example, Microsoft has a money data type that's simply been created as a decimal column in the DB2 table. I can click the sample button. Okay, the table's there, but of course we have no data. Let's do a load. So this, I can now run a job to load the data from the remote table into this data source. So it's going to use this simple SQL expression here now and click OK. Now this might take a few minutes to run. So rather than waiting at the client here for it to complete, it has submitted a job and I can click on the jobs button. It's or has already completed and let's sample it. There's the data. So we have just loaded the data from the remote Microsoft table into our local DB2 table. Now it's available to me as static data that I can use for loading in one or more ETL processes. Now in that process, I selected all of the data in the remote table, but I can choose to use an SQL expression to select the data that I want to load. So I can for example, I can say where status equals 5, which I happen to know all of the data in the table has a status of 5. I can also use runtime variables, load parameters. So I can create a parameter, give it a name, a description, a type, and a value, and that value can be specified at runtime. So I can do dynamic selection based on the day or whatever other attributes I care to choose. Okay, so quick and easy to implement or to introduce remote tables in Microsoft SQL Server or Oracle or MySQL. They all work in exactly the same way. What about IFS text files, streaming files? I already have one that I've introduced here. This is a customer file, so it's in a folder and the IFS. Let's have a look at this one. Okay, so, and click the columns. Actually, let's take a step backwards. Let me click the sample button. Now, how many records do I want to sample from that IFS file? It might have hundreds of thousands. We're only going to sample 1,000. So here is the raw data. So as we can see, it is it's not a delimited file. It's each record is simply formatted as if there were columns there, but of course, being a text file, there are no real column definitions. Now let's go back and have a look at the properties again. Click on columns. And here we can see that we've used markers to identify where each column begins and ends. Each time a marker is placed, it creates a column definition in our metadata, and we can give it each one a column name. So I've already gone through the process of placing the markers, identifying, giving it each column a name. But now I've described the format of this record or this table, this file, and now I can use it in an ETL process just as if it was an externally described file or table. What about delimited ones? So let's introduce a delimited file from the IFS. So I'm going to use my text files group, and this is a zip code file. I'm going to browse, and we're already looking in the right folder, and it's the zip code database. Select. This happens to have a header row, which I can use to name the columns. So I'm going to select, specify that it has one header row. If it had a comma for a decimal point or a specific currency symbol that was used, I could specify them here. This one does not. Click next. How many rows do I want to look at? So it's got to analyze the contents of the table to try to understand the data type between each delimiter. Okay, it has identified that it's delimited. Also asking me here, is there a string delimiter? Is there a field delimiter? And again, if there are any formatted dates, what format they would be in. Is that the header row that I want to use? Yep, that's the one. So I will say yes, select that one. And next. Now look what's happened. Here is the raw data with the delimited values. In this case, it's delimited by a comma, and it uses delimiters to identify the columns that exist in this delimited file. And it's also analyzed the data to determine that this first column looks like it's numeric. All the values that were analyzed are numeric values. The second column is a single character. The third column is a character with a length of 22. And we have used the header row to identify the column names. Next, finished, done. Now the zip codes, that zip codes delimited file can be used to in an ETL process with and referring to all of the values by their identified column name. Okay, that concludes the demonstration for today. It shows how easy it is to introduce different data sources and make them accessible to be used in an ETL process. In another video in this series, we'll take a look at the ETL process itself.